Morning, guys. Is everything all right? Audio, video, and all those things. Then we can start our session. Today we'll be discussing matrix. So previously we have covered two portions of the matrix, and this is the third part of the matrix. Audio, video. Guys, now till now we have covered 9 lectures, and from the 9 lectures, if you have any doubt, you can ask me anytime. You can also share it on WhatsApp. You just need to click a picture of your doubts and you can ask the doubt. And also you should also do the homework problems, and maybe in 2-3 days we'll also share the assignments, and from the assignment you can start solving questions. Although we'll try to solve questions mostly in the class itself. Okay, more problem oriented sessions. So this is the third part, and today we'll start with rotation matrices. So have you done the yesterday's homework problem? Could you find the correct answer? You can share it in the group. Okay, so today we'll start with rotation matrix. So many times you have seen in examination question paper that you are asked to specify a matrix or a vector after certain rotation. So you are given a situation like this vector or this matrix is rotated by some angle. What will be the new matrix? So for that cases, this will be very much helpful. Let's say I am making rotation. So as you know, 3 axes are there. Let's say this is your x-axis, this is your x cap axis, let's say this is y cap, and this is z cap. So you can make the rotation about x-axis, about y-axis, and about z-axis. So if you make a rotation about x-axis, the x-axis will remain fixed and y-z axis will rotate. Okay, so let's say I am rotating about x-axis. I am rotating about x-axis in the anti-clockwise sense. Anti-clockwise sense. In an anti-clockwise direction by an angle, let's say theta. Then the corresponding rotation matrix will be, so this is the first case, rotation about x-axis. Rotation about x-axis. Option A, you got it? Okay. So an option will come like in the form alpha square plus beta square plus gamma square plus delta square equals to 1. Something like that, as I remember. Look, rotation about x-axis is given by this rotation matrix. Let's say Rx. Yes, Rx. So you already know the value. The matrix will be 1, 0, 0, 0 cos theta minus sin theta, then 0 sin theta cos theta. So if you rotate about x-axis by some angle theta in the anti-clockwise direction, then this formula you get. Okay. Now similarly, you can make a rotation about y-axis. When you are making the rotation about y-axis, what will remain fixed? X, y, z. So you see this y-axis in the anti-clockwise sense by some angle theta. So if you are rotating about y-axis remains fixed and this z-x plane will rotate. So if you rotate it by some angle theta, then the corresponding matrix will be rotation about y-axis. So any axis they can give you, generally they give z-axis, okay, but you should know all the axes. Okay, for y, you see there is a pattern 1 0 0 when you talk about Rx. For y, this will be like this 1. Okay, this symmetry is done. Then your this thing cos theta, sin theta minus sin theta cos theta. Slightly notice here it was cos theta minus sin theta, but for y it will be cos theta plus sin theta, then minus sin theta, then cos theta. So you have to remember a little bit, okay, you have to be a little bit careful here. Then the third one, rotation about z axis. So for this case we are giving the rotation about the z axis. So draw it again this way, x cap, y cap and z cap. So you are now carrying out the rotation about z axis, and you see each and every case we are carrying out the rotation about in the anti-clockwise direction by some angle theta. Okay, and the rotation matrix about z axis will be, now look, for Rx it was 1 0 0 0 0 0. For z axis let's write, look, x, for x 1 was coming here at 1 1 position, for y 1 was coming at 2 2 position, for z it will come at 3 3 positions. Okay, 0 0 0 0. Now here this matrix will be there, cos theta minus sin theta, sin theta, cos theta. So one way to remember it, you see, for Rx and Rz, this unit is same, cos theta minus sin theta, cos theta. You just remember this one, cos theta minus sin theta, cos theta minus sin theta, cos theta. For Rx and Rz, these two are same. For Ri, this minus sin theta is plus sin theta and minus sin theta. In this way you can remember. So you can also write some note here. Note, the first note we have already told you, for this given rotation matrices, the rotation is carried out in the anti-clockwise direction, anti-clockwise direction. Now instead of giving a rotation of theta in the anti-clockwise direction, if you give it in clockwise direction, what you gonna do? You can just replace theta by minus theta, right? It's very straightforward to think. If rotation is carried out in the clockwise direction, then theta will be replaced by minus theta. Now you see, for cos of minus theta is plus cos theta, and sine of minus theta is minus sine theta. So whenever you see sine theta, the corresponding sign will be opposite. Here if you for cos theta there will be no change. Cos of minus theta is equals to cos theta. So this sign will be changed. It will become plus sine theta, it will become minus sine theta. Minus sine theta, plus sine theta, plus sine theta, minus sine theta. I hope you have understood. Let's go for a problem now. If it is done, very simple thing. Now one more thing is there. Sometimes you may be given some rotation matrix, and some matrix you may be given, and you may be asked whether it is corresponding to rotation or reflection. So if you get determinant of some matrix, let us say R, if it is plus 1, then it is corresponding to rotation, okay, and if it is it is equals to minus 1, then it corresponds to reflection. So these two things you should keep in mind. Let's solve a problem. Yeah, these are, there may be some rigorous proof of obtaining these matrices, but you have to remember these matrices, okay. In your examination you have to directly use this. So what kind of thing you can expect here? Let's say you may be given a vector, okay, then it may ask you, like, this vector has been rotated in the counterclockwise direction by some angle. This theta value will be given, let's say 30 degree or 45 degree. What will be the new vector? In this way question will be framed. So these are very standard results which you should remember, okay. चलो problem करते हैं. Let's do a problem. Look at this problem. Consider a vector I cap plus 2j cap plus k cap in the coordinate system ijk. The axes are rotated in the clockwise direction about the z axis by an angle 45. So theta equals to 45. The vector p in the rotated coordinate system will be. Understood what you have to do? Rotation has been carried out about z axis, means you have to operate rz on this vector p. So if I give you a hint, it is like rz operated on some vector x, let's say, and it is producing x prime. So you have to find out this x prime. X is given to you in this way. So x is given to you 1 2 1. So you can take it in this way, 1 2 1, right? So do this. Tell me the answer quickly. So if you try to visualize the scenario, what kind of scenario we can expect? So this is the unrotated system, previously x cap, y cap, z cap. So rotation is carried out about z axis. So after rotation, you see you are rotating it clockwise. So in this direction, in this way, you are rotating clockwise. So what you can expect? Your y axis will come here, okay, 45 degree. So it leads something like this, and your x axis will go there. So this is your, let's say, x prime, this is your y prime. Now rotation is carried out over z axis, so z axis will remain fixed. This angle is 45 degree. C option, very correct. Option C will come. So let's do the solution. So let's say the new vector is x prime. So we are writing the component as x prime, y prime, z prime, which is the thing we have to find out. Now what about the matrix? Cos 45. So the third one, you will be cos 45, and this minus sin theta will be plus sin theta. Sin 45 minus sin 45, sin 45 minus sin 45, and cos 45 will remain as it is. And this is 0, 0, 1, 0, 0. This is 1, 2, 1. Now this is a 3 by 3 matrix. This is 3 by 1. So you know the multiplied or product matrix will be 3 by 1. 3 by 1 means it's a column matrix. Cos 45 1 by root 2 plus this 2 by root 2. 1 by root 2 plus 2 by root 2, and for the second one you see minus 1 by root 2 plus 2 by root 2, and this is 1, isn't it? So what you get ultimately, this is equals to 3 by root 2, and this is 1 upon root 2, this is 1. So 3 by root 2 I cap plus 1 by root 2 j cap plus k cap. So option C. Yes, Deep. Now do this problem. Which one of the following matrices does not represent a proper rotation in a plane? A, B, C and D. Which one? D. Very good. So you know whichever determinant will give you 1, that will be corresponding to the rotation matrix. Now for option A, you see sin square theta plus cos square theta, that is 1. So this is satisfying. This is cos theta plus sin theta, this is 1, this is also 1, but this is minus 1. Okay, so this represents reflection, not rotation. So determinant of m is equals to this, let's say, minus sin theta minus cos theta minus 1. Therefore, it does not represent a proper rotation. Okay. Now next we are going to discuss about a very important topic of similarity transformation. Similarity transformation and diagonalization of matrix. So many questions come from this particular topic. Let's start with similarity transformation. So I think you know about it. Do you know what is similarity transformation? Do you remember the vector operation? What was there in similarity transformation? Any clue? So for this we are taking two square matrices. Let A and B are two square matrices of order, let's say, n. Then B is said to be similar to A if there exists a non-singular matrix. Non-singular, I have already defined. What is non-singular? Having non-zero determinant. If there exists a non-singular matrix P such that B can be written as P inverse AP. Okay, so this is called the similarity transformation. This is the similarity transformation. And these two matrices A and B are called similar matrices. So what you have here in the case of similarity transformation, you see a vector, a matrix has been pre-multiplied by some matrix and post-multiplied by some matrix. So matrix is pre-multiplied and post-multiplied by another matrix and its inverse. Now there are some properties of similar matrices. What are those properties? Properties of similar matrices. Matrices which are formed by similarity transformation. So for these two matrices A and B, what are the properties are same? They have equal determinants. Okay, so number one, they will have equal determinants. This is the first point, that is determinant of A is equals to determinant of B. What is the second point? Yes, Ajay, the same characteristic equation. The same characteristic equation. Do you know what is the characteristic equation? in finding the eigenvalues, we introduce this term characteristic equation. So when you find out the characteristic equation, we write A minus lambda I. Okay, characteristic equation means this modulus equals to 0, B minus lambda I. These are the characteristic equation. The both characteristic equation are same. Third, the same eigenvalues. They will have the same eigenvalues, but not necessarily same eigenvectors. But not necessarily the same eigenvector. So same eigenvalues means trace will be same. Trace of A is equals to trace of B. Is it clear? So you need to remember these properties. Question may be asked in any form. You may be given two matrices, and you may be asked which option is correct. So in one option they give you like they have same determinant, same characteristic equation, same eigenvalues, same eigenvectors. So it may ask you which is not true or not correct. Then you can use these properties. Now similarity transformation, why it is so important? Similarity transformation helps us diagonalizing a matrix. What is diagonalizing a matrix or diagonalization of a matrix? If you have, I'm giving you a matrix. After diagonalization, only the principal diagonal elements will remain. All other off diagonal elements will be 0. That is the meaning of diagonalized matrix or diagonalization. Okay. If this is done, we can go. Let's see these notes on diagonalization of matrix. Okay, you see, diagonalization of a matrix is the process of reduction of A to a diagonal form D. If A is related to D by similarity transformation such that D is equals to P inverse AP, then A is reduced to the diagonal matrix through the modal matrix P. The matrix P is known as modal matrix. Okay, modal matrix, and this diagonalized matrix is known as the spectral matrix, and this is the condition. D is equals to P inverse AP. The square matrix P, which diagonalizes A, is found by grouping the eigenvectors. This is very important. Grouping the eigenvectors of A into square matrix, and the resulting diagonal matrix has the eigenvalue of A as these diagonal elements. We will be solving problem, don't worry. You just write down, okay? The transformation matrix of A to P inverse AP is known as similarity transformation, as I told you. This is a particular case of similarity transformation. As I told you, this is a particular case. Similarity transformation is a more general thing. Diagonalization is one of its application. Particular case of similarity transformation. So how do you do it? Let's say you are given a matrix A. Okay, you have to find out first P. P, how can you find it? You will get the eigenvalue. Let's say lambda 1, lambda 2, lambda 3, and corresponding to this you will get eigenvectors. Okay, let's say A1, A2, A3. This is eigenvector x1, eigenvector x2 corresponding lambda 2. You get, let's say, B1, b2, b3. Then corresponding to lambda 3 you can find out eigenvector as a c1, c2, c3. Then you just need to group this. So this p will be found by grouping this a1, a2, a3, b1, b2, b3, c1, c2, c3. Once p is found, you can easily find out p inverse. Then if you find this product p inverse ap, then you will get this diagonalized matrix. So in the diagonalized matrix, ultimately you will only have the diagonal elements. Okay, diagonal elements will be there, all other elements will be 0. Now try to understand this note very carefully. If an n by n square matrix A is diagonalizable if and only if it has n linearly independent eigenvectors. So these x1, x2, x3, they should be linearly independent. In this case, you can write a diagonalized matrix D by replacing the corresponding eigenvalues along the diagonal. So you don't need to do this P inverse AP. You can directly put this lambda 1, lambda 2, lambda 3 along the diagonals here. Lambda 1, lambda 2, lambda 3. Am I obstructing? So let's try to understand this diagonalization process by some example. Let me know once when you have written this slide. Okay, then we'll move forward. Ajay, Deep, Muralidharan, just confirm whether you have finished writing this. Then we'll go to the next slide. In the meantime, everybody like the video, okay? Just write done when you are done. Hurry up, guys. Okay, so let's move forward. You have to diagonalize this matrix A equals to this. So let's start. What we have to do? Firstly, you have to find out the eigenvalue equation. You have to find out the eigenvalue. So eigenvalue equation you found. So A minus lambda I equals to 0. So you see minus lambda minus I plus I minus lambda equals to 0, lambda square plus 1, sorry, minus 1 over minus 1 equals to 0, lambda is equals to plus minus 1. So we can say that one eigenvalue is 1, another eigenvalue is minus 1. Okay. Now we have to find out the eigenvectors corresponding to lambda 1 equals to 1 and lambda 2 equals to minus 1. So you know the corresponding eigenvector, let's say x1. So we can write a x1 is equals to lambda 1 x1. In the lecture of eigenvalue and eigenvector, I have already told you how to find out the eigenvector. So the same thing we are doing here. So a is 0 minus I plus I 0, x1, the components are, let's say x1 x2, lambda 1 is 1 times x1 x2. So this is minus I times x2, this is I times x1, this is equals to x1 x2. So what we can write? We can write x2 is equals to I times x1. Okay, x2 is equals to 1 by minus I, so I times x1, and from this one also you can say I x1 is equals to x2. So let x1 is any value k, therefore x2 will be I times k, and hence your x1 will be k ik, right? So using the normalization condition, what you have to do, x1 dagger x1 equals to 1. This is the normalization condition. x1 is this column matrix, x1 dagger will be a row matrix, right, k star, and minus I, k star is x1 dagger and x1 is this k ik. I am doing each and every step so that you understand. Okay, from this you can see this k star k, so mod k square plus again mod k square equals to 1, and this gives you k is equals to 1 upon root 2. So you can now easily write the value of x1, the matrix x1 is equals to 1 upon root 2 and I times 1 upon root 2. This is x1, this is corresponding to lambda 1 equals to 1. So if you find out in a similar manner for lambda 2 is equals to minus 1, for lambda 2 is equals to minus 1, you will get the eigenvector, let's say x2. So what changes will be there? You can calculate it in this manner as I have shown you. Only minus sign will come here for the second element, minus I by root 2 will be there. So once x1 and x2 is found, what will be p? P will be formed by writing the eigenvectors side by side, like x1 x2, right? This is 1 upon root 2 I upon root 2 1 upon root 2 minus I upon root 2. So we have got our p, and p inverse you can also find. P inverse you can find adjoint of p by determinant of p. So if you calculate it, you will get this matrix 1 upon root 2 minus I upon root 2 1 upon root 2 I upon root 2. You can do it by yourselves, very straightforward. So you have got p and p inverse. Therefore your diagonalized matrix, this is diagonalized matrix. Formula P inverse A P, right? So P inverse we have got 1 by root 2 minus I by root 2, 1 by root 2, I by root 2. This is P inverse A. It is given in the question 0 minus I plus I 0, and P is 1 upon root 2, 1 upon root 2, I by root 2 minus I by root 2. So 3 products are there, so we can just take 2 of them and multiply with the remaining. So let's say we are keeping the first matrix as it is, 1 by root 2 minus I by root 2, 1 by root 2 I by root 2, and this will be your 1 by root 2 minus, you can do it by yourself, okay guys, just do it by yourself and match with my result. What is expected? 1 0 0 minus 1. So if you closely notices, what is ultimately we have got this. What are these numbers? 1 minus 1. They are looking very bad. What are these numbers? These were the eigenvalues, right? Which is ultimately coming after all these operations. Okay, lambda 1 equals to 1 we have got, lambda 2 is equals to minus 1 we have got. So this is written in the principal diagonal. Got it? Tell me guys if you have understood or not. Simple thing, just little bit of calculation which you need to be doing very carefully, otherwise things are okay. To stress this fact, let's take another example. If I take another matrix, let's say another matrix, A is equals to, let's say 4 1 2 3. If you start diagonalizing this matrix, how to do? Again, let's write the characteristic equation of the matrix. A minus lambda I will be 0. So 4 minus lambda, 1 2 3 minus lambda, this will be equals to 0. 4 minus lambda, 3 minus lambda minus 2 equals to 0. So this is equals to lambda square, minus 4 lambda minus 3 lambda minus 7 lambda plus 12 minus 10 minus 2, so plus 10, and this gives you lambda minus 5 lambda minus 2. Okay, therefore lambda is equals to 2 5. Write the smaller eigenvalue first, then the larger eigenvalue. So what do you expect? We can imagine that the diagonalized matrix will be of this form, 2 5. Just writing the eigenvalues along the principal diagonal. This is our expected. P inverse given by U is correct. Is it incorrect? Harani Vishnu. Are you getting a different result for P inverse? I think it will be the case. For P, you have to find out cofactor, then you have to find out the transpose. This from determinant P, one I will come. You have to consider that also. I think this is correct. Okay. Look at this. So this is our expectation that we will get it in this way. Now let's check it. D is equals to P inverse AP. So I am just directly giving you this result. P inverse will come 1/3 1 2 minus 1 plus 1. You can cross verify at home, okay, or now also you can do. Ultimately you will get this result. So the main point here is that the eigenvalues will be written as principal diagonal and you will get the diagonalized result. Okay. So these are the two examples. At your home you can try it by actually calculating everything. Okay, I am just giving you this example just to make you understand what is happening. Now let's take a 3 by 3 matrix, and what will happen if two eigenvalues are equal. Let's take that case. Let us now take this matrix A, which is given by this 6 minus 2 plus 2 minus 2 3 minus 1 2 minus 1 3. Okay. Again, characteristic equation A minus lambda I equals to 0, 6 minus lambda, 3 minus lambda, 3 minus lambda, minus 2 plus 2 minus 2 minus 1 2 minus 1. This is equals to 0. Now let's calculate it. 6 minus lambda, 9 minus plus lambda square minus 6 lambda minus 1 minus 1 is plus 2 minus 6 plus 2 lambda plus 2 plus 2 2 minus 6 plus 2 lambda equals to 0. Now if you calculate it, I am just writing the ultimate result. You can do simplify this. Lambda cube minus 12 lambda square plus 36 lambda minus 32. This is equals to 0, and this will give you 3 values of lambda minus 2 whole square, lambda minus 8 equals to 0. This gives you lambda is equals to 2, 2 and 8. So you see these two eigenvalues are same. Still, ultimately you will get the diagonalized matrix in this form 2, 2, 8. Let's verify this. So what you have to do? You have to find out the eigenvector corresponding to lambda equals to 2. Okay. So let's say ax1 is equals to lambda 1 x1. Lambda 1 is equals to 2. So it is a minus lambda 1 I times x1 equals to 0. I is multiplied by lambda 1 is a number, but A is a matrix. So to make it compatible, we have to multiply with identity matrix. Okay. So A minus lambda I means subtracting lambda 1 from the diagonal elements. So 6 will be 4, 3 will be 1, 3 will be 1, isn't it? So this will become 4 minus 2 plus 2 minus 2 plus 1 minus 1, 2 minus 1 plus 1. x1 will contain 3 elements, x1, x2, x3, let's say. This is equals to 0. Okay. And this will give you 4x1 minus 2x2 plus 2x3 minus 2x1 plus x2 minus x3, 2x1 minus x2 plus x3. Now equate. Look, we can write 4x1 minus 2x2 plus 2x3 equals to 0, and that gives us 2x1 minus x2 plus x3 equals to 0. And this is exactly the second relation, third relation, giving you the same result. When you just take a negative sign out of it and absorb in 0, 2x1 minus x2 plus x3, and it is already given in the third, 2x1 minus x2 plus x3. Now look, by choosing the values of x1, x2 and x3, we can make it 0. One such example I am giving you. Let's say if you take x1 is equals to 0, x2 equals to, let's say, 1, x3 equals to 1, then it is 0. Another possibility, you can take x1 equals to, let's say, 1, x2 is equals to 3, x3 is equals to 1, then again it is 0. And as you can see, we can call it x1 as 0, 1, 1, isn't it? Because lambda equals to 2 appearing twice. So 2 eigenvectors we can expect. So one eigenvector is 0, 1, 1, another eigenvector 1, 3, 1, and as you can see they are linearly independent. Now let's go back to this condition which I have given you as note. If an n by n square matrix A is diagonalized even if and only if it has n linearly independent eigenvectors. In this case, you can write the diagonal matrix D by placing the corresponding eigenvalues along the diagonal. Okay. So x1, x2, you have got this one. Now another eigenvalue is remaining, that is lambda is equals to 8. For lambda equals to 8, you will get x3 2 minus 1 plus 1. You can calculate it by yourself, but you will get it like this. So D, the diagonalized matrix, these three x1, x2, x3, they are linearly independent vectors. So as per the rule, we just need to write the eigenvalues along the principal diagonal and other elements 0, then it should give you the diagonalized matrix. So very straightforward. Look, if your concept is clear, everything will appear to very easy, otherwise everything will be very complicated. I think you now have understood this process of diagonalization. Will you be able to handle everything now from diagonalization? Now this diagonalization is very important. Why? It will help you to find out various operations. You can find out power of a matrix, you can find out exponential of a matrix, logarithm of a matrix, and many other things. Is it done? चलो आगे बढ़ते हैं. Let me show you now calculation of the power of a matrix. Power of a matrix. So you see, as per similarity transformation, D is equals to P inverse AP. So we can get back our original matrix A by pre-multiplying by P, post multiplying by P inverse. So P inverse is identity. So multiplying by P D P inverse. देखो ये समझ में आया? If you multiply P on both sides, so PD, P inverse is identity, post multiplied by P inverse, so PD P inverse equals to A. So any power of this given matrix A to the power k, it is P D to the power k P inverse. K is a positive integer. You just need to focus on the diagonal elements. Whatever operation you will be doing with the matrix, the same operation will be done with the diagonalized matrix. In this way you can find out the power of a matrix. Now exponential of a matrix. Why should we prefer x0 1 1 with a lot of chances to make it 0? Tell me what are the other ways? Two ways I have shown, 0 1 1 1 3 1. Can you tell me, is there any other way? I think you will only find these two. Tell me if you can find out any other combination. You will think about it, okay? If you find any other combination. We have to find out the linearly independent solution. I have already given you two linearly independent solutions. That is enough, na? That is enough to write these three elements along the principal diagonal elements, because this is a 3 by 3 matrix. So you need to find out three linearly independent vectors. So corresponding to lambda is equals to 2, we got two linearly independent vectors, and for the third one another one. So that is sufficient, and you will not get, I think. Is there any other combination? I don't think so. Go. Exponential of a matrix. So we are directly starting with this A is equals to P D P inverse. This is we are getting from the similarity transformation. Exponential of A will be equals to P, whatever operation you will be doing with A, the same operation should be done with the diagonalized matrix. Okay, like this. Similarly, logarithm of a matrix will be done 0 to 2. Yes, with 0 to 2 also, but 0 to 2 is just 0 to 2 is not linearly independent. Na? It is like we have got, let's say, x1 0 1 1. You are saying, let's say, 0 to 2, but 0 to 2 we can write it in this way, na? 2 times 0 1 1. So 0 to 2 will not be counted. We have to find out linearly independent. This is not linearly independent. So linearly independent, you will only find these two. So you can say we can get 2 6 2 also. I think you got my point, Murli. A is equals to P D P inverse. Logarithm of A, P, logarithm of D, P inverse. So any operation you do with A, that will be reflected in the diagonalized matrix. Noted these three formula down. Let's go for a problem. Look, I have just given you only 3 operations, but similar operation may appear in your examination. One such example, where is that? Yes, look at this problem. Given matrix M, you have to find out cos m pi by 6. So little bit complicated operation you have to do. Okay. You can take pi m by 6 as another matrix, then it is like, let's take n is equals to pi m by 6. So you just need to find out cos n. Okay, na? Instead of going with m, you go with n. Okay, let's start together. I am doing, you also do. Okay. You have given matrix given m is equals to 2 1 1 2. You have to find out cos m pi by 6. So pi m by 6, let's tackle that first. So we are considering n is equals to pi m by 6. So ultimately we have to find out cos n. So what will be the value of n? N has been found by multiplying pi by 6 with each element. So pi by 3, pi by 6, pi by 6, pi by 3. Now what you have to do? You have to find out the eigenvalues. So n minus lambda I equals to 0, you will do that pi by 3 minus lambda, pi by 3 minus lambda, pi by 6, pi by 6, this equals to 0, and this will give you two values of lambda. Pi by 3 minus lambda whole square minus pi by 6 lambda whole square, pi by 6 whole square, this will give you pi by 3 minus lambda plus pi by 6, a square minus b square formula, a plus b, a minus b, and this will give you the two values of lambda. One is pi by 6, another one is pi by 2. Okay. So you know what will be the diagonalized matrix. You can write them by writing these diagonals side by side. But you see, if you want to calculate this operation cos of thing, as we have seen it here, either you want to calculate a to the power k or exponential a, you must find out p and p inverse. So although we can write the diagonalized matrix, it is not asking about finding the diagonalized matrix, but it is asking about cos of that thing. So you must find out p. We cannot avoid the calculation here. Okay. So let's calculate the eigenvectors corresponding to, let's say, lambda 1 is equals to pi by 6. So our original matrix, our matrix now is n x1 lambda 1 x1. Okay. Pi by 3, pi by 6, pi by 6, pi by 3, x1, let's say x1, x2, pi by 6, x1, x2. Don't be lazy in doing these calculations. It should be very much active. This one equation you will get considering the first row and considering the second row. You will get this one. Let's say this is equation number 1, equation number 2. Now if you multiply equation number 1 by pi by 6, let's say 6 by pi, what you gonna get? 2x1 plus x2 is equals to x1, and 2 also 6 by pi, x1 plus 2x2 plus equals to x2. So what is your conclusion from here? It gives you x1 is equals to minus x2. Here also x1 is equals to minus x2. So we can let x1 is equals to k and x2 will become minus k and x1 will be k minus k. Normalization condition, x1 dagger x1 equals to 1, k star minus k star, k minus k, k star, and k mod k square 1 upon root 2. So you are getting x1 to be 1 upon root 2 minus 1 upon root 2. Now similarly, if you calculate for lambda 2 is equals to pi by 2. Pi by 2 I have got, no? Yes. You will get x2 1 by root 2 1 by root 2. So what will be p? P is equals to x1 x2 1 by root 2 minus 1 by root 2 1 by root 2 1 by root 2. Adjoint of p, let us say calculate, p inverse we are going to calculate. 1 by root 2 minus 1 by root 2 plus 1 by root 2 plus 1 by root 2. Cofactor transpose. And if you calculate a determinant of p is half plus half 1, no issue. So p inverse adjoint of p by modulus of p. So adjoint of p basically 1 upon root 2 minus 1 upon root 2 1 upon root 2 1 upon root 2. So you got p inverse. Now n, which is pi m by 6, p d p inverse. Look, previously it was p inverse that np. So n equals to p d p inverse. So what is cos n? Cos pi m by 6 p cos d p inverse 1 by root 2 minus 1 by root 2 plus 1 by root 2 1 by root 2 cos d. D we have got here, only we can find out d by writing the diagonal elements, the eigenvalues, the diagonal elements, isn't it? Pi by 6 0, pi by 2. So it will become cos pi by 6 cos pi by 2 0 0. And here it is 1 by root 2 minus 1 by root 2 1 by root 2 1 by root 2. Now you just need to multiply these three matrices now. Let's keep the first one first. Pi by 6 cos 30 cos pi by 2 is 0. So this will give you root 3 by 2 root 2 minus root 3 by 2 root 2 0 0. And if you calculate, this will give you root 3 by 4 minus root 3 by 4 minus root 3 by 4 plus root 3 by 4. So we can write it cos pi m by 6 root 3 by 4, you take common 1 minus 1 plus 1. Such a long problem but you should practice it just to understand the process. Okay, in your examination you may be given little shorter problems, so it is matching with option B. One problem we will do, then we will wrap up the session. Okay, today. Let me know once it is done. Okay, one problem I am just giving as homework. You can try it at home and you can send the solution in the WhatsApp group. Okay, take this problem as homework. Simple problem, you will try at home. A matrix C is given by this. Using similarity transformation, matrix C is transformed into a diagonal matrix D. The matrix e to the power pi d. It's so simple. Diagonal matrix you can find out by first you have to find out the eigenvalues. 3 eigenvalues you will get lambda 1, lambda 2, lambda 3. So from the characteristic equation you will first find out lambda 1, lambda 2, lambda 3. Then D will be written in this way, lambda 1, lambda 2, lambda 3. Once D is obtained, you know what to do. E to the power pi d means e to the power lambda 1, e to the power lambda 2, e to the power lambda 3. That you have to find out. Okay, so you will do this problem at home and you will share it in the WhatsApp group. Okay, I am trying to give you 1 or 2 problems as homework so that you go to home and you just see the things and try to revise the classes regularly. That will be very effective. Let me tell you, if you don't revise, if you just attend the classes, that will not be so much effective. But if you revise the things, look, I am giving you, let's say I am taking 1 hour class or 1.5 hours class, but when you revise, you can revise it maybe 15-20 minutes. It will not take more than that because you have just freshly learned those things. So revision will not take much time. So if you do it every day, then it will definitely help you a lot. With this note, let's end the session here today. If you have any question, you can ask. Otherwise, we are ending the session. So have a great day, guys. Bye bye. Take care.